Well, let me tell you, it's a real pleasure to be here. It's my second time in Wisconsin, but I've never been to the Dairy Expo, and so it's really exciting for me to see all this here. As you know, California dairies look a little different. They're also probably regulated more than you are in this state at this time. Just to give you an idea, our dairies are fully regulated for air quality, just like any other industry. So whether you are a factory or a dry cleaner or a dairy, you have to have an air permit to operate. So for example, if you have a dairy and you want to build a new freestall barn, you need to get an air permit for that. If you want to add 100 cows to your 1,000 cow herd, you need to get an air permit for that. You can have whatever you have on your permit, and if you want to make a change to that operation, you need to get an adjustment, and you need to, and you will be inspected once a year by the air district, who will follow through and see whether or not everything that you have on paper is actually what you do. So air quality is not something that is just on paper there, but it's something that, that really impacts the dairy industry in the state. We have about 1,600 dairies. The average size is 1,000 cows, but the dairies are increasing, they're growing. The total numbers of cows is staying stagnant, but we have lost about 400 dairies the last 10 years or so. But the remaining ones are getting bigger, and so the total numbers of cows are staying the same. What I want to do today, for you today is talk a little bit about air quality and some of the major issues that we face over in the West, and also share some of the regulatory issues that we have, and talk about air quality, but also talk about climate change, because many of you are aware that dairies are often associated with impacts to climate change. So when you think of air pollution and air pollutant sources, what do you think of? What do you think of? What are the sources that produce air pollution? Cars. What else? Yep. Coal burning plants. Yep. What else? Come on. Transportation in general, exactly, yeah. So there are factories and planes and ships and cars and trucks and, you know, you name it. Of course, agriculture also produces air pollution, right? That's true. For example, during land preparation, when you plow the fields, you will generate some dust. Also, dairies produce air pollutants. What do dairies produce? Ammonia. Hydrogen sulfide. Particulate matter. Methane, exactly. And in the state of California, these things are now regulated. Okay? And I don't have to be a prophet to tell you that this is about to hit you too. So, but today I will focus on select pollutants. Now the light is not optimal here, but I hope you will see this satellite image here. It shows California, and this is California, circled by my laser pointer. And so this is Los Angeles down here, this is the Bay Area, San Francisco, this is Sacramento. This here is the nation's most fertile area. It's called the Central Valley. And between Sacramento and Bakersfield is what we call the San Joaquin Valley. San Joaquin Valley is surrounded by the Sierra Nevada on the east side and the coastal mountain range on the west side. So it's basically a big old trough. And the reason why this is relevant is because this trough here traps any kind of air pollutants, because they have no place to go. Anything that's produced in this trough, in this valley, stays there for a long period of time. And all the different pollutants can combine and form new pollutants. And that's the reason why Fresno, right in the heart of the San Joaquin Valley here, has the worst air quality in the United States. Okay, because it's that air shed that's so trapped. The number 2 is Los Angeles, and the number 3 is Houston, Texas. And the reason why this is important to the dairy industry is because this is the location of 20% of the US cow herd, dairy cow herd. 20% of all US cows are located in the San Joaquin Valley. And again, in the heart of it, in Fresno County, we have the worst air quality in the nation. Now, when you think of air pollution, when you think of air quality issues, you might think of those pollutant sources that are right in your neighborhood, okay, that really affect you directly. Let's say a swine operation a mile down or away from your house might affect you with respect to odors, or you might smell trucks driving by your house or so. But what many people don't think of is that air pollution travels. Air pollution can travel very far distances and not just a couple hundred yards. And this slide here will show what I'm describing to you. This is Australia down here. This is China up here. This is North America, Mexico, United States. And this is the Pacific. And in a second, I will animate this slide, and you will see how air pollution travels long distance. So this is China over here. And as you can see, it takes about 4 days to reach the United States. So air pollution that's formed over China takes 4 days to get here. Approximately 10% of the pollutants that we measure in California originate in China. That's why it's so important to get an understanding of, first of all, what forms pollutants, but also what happens to these pollutants once they are in the air. Where do they go, and what happens to them? Can they convert from one pollutant form into another? What you might also not appreciate is that there are pollutant sources that we cannot regulate because they occur over international regions, like the oceans. This slide here is a very important one, I think. It shows California here, circled by my laser. And then what you see here, those black lines are ship tracks. These are smokestacks of container ships. The container ships that land in Long Beach near Los Angeles, these container ships produce more air pollution compared to all the vehicles in Los Angeles combined. Yet nobody ever talks about that. Nobody has ever really talked about these type of pollutants. Why does that matter to us? It matters because these pollutants eventually end up in those air sheds that we are concerned with. So when we talk about air pollutants, it's very important to keep your eyes open, make sure that you don't just regulate what you see, cows and cars and so on, but really what contributes to that pollutant picture overall. And this is a slide, this is my favorite slide in the world. It shows a fence line. On the one side, it shows 1,000 happy California cows, and on the other side, 1,000 unhappy California neighbors. Those neighbors moved next to that dairy within the last 5 or 10 years, and guess what the first course of action for those neighbors was? To sue the dairy for nuisances. So these people come from urban areas, they move right into agricultural areas, and then they complain about those nuisances that affect their way of living. So I often talk in front of audiences like this, but also more urban ones, and I ask them, this dairy here has the same spatial footprint compared to this residential area. There are 1,000 homes on this side, and there are 1,000 cows on this side. Now, what do you think has a greater environmental footprint on the land? The 1,000 homes with the 2,000 cars and lawnmowers and leaf blowers and people flying around the country all the time on this side of the fence, or the 1,000 cows on this side of the fence? Yet these people here, they point their finger onto the other side, not noticing that 3 fingers are really pointing back at them. This is a very important picture, I think, because these people have no understanding what their contribution is overall compared to agriculture's contribution. No understanding. The general public has very little understanding of where their food comes from and what kind of impacts are involved and what they hear, whether or not it's true or not. And I will give you some examples. When I came to California, I started my position there in 2002. In 2004, I looked at the emission inventory for smog-forming gases in the state of California. Smog is the big air pollutant problem we have. So I looked at what are the top 25 sources producing smog, smog-forming gases. And what you see here is an official emission inventory from the time, which lists dairy cows as the number 1. Dairy cows, the number 1 source of smog-forming gases, followed by trucks, followed by cars. And then there are other agricultural commodities. Down here, number 12 are wineries. Down here, number 18 are broilers. Number 20, range cattle. Number 23, feedlot cattle. So I asked myself, how can that be that cows produce more smog than cars? How is that possible? It defeats common sense, right? So I challenged my team with finding out, first of all, where these numbers come from and whether or not they can be true. And so at the time that this emission inventory came out, the media was all over the place saying cows should be smog checked and articles like this, Cows Rival Cars as Smog Producers, the reputation or the effect it had on the reputation of the dairy industry was tremendous. And so you might know what a California dairy looks like. The dry cows are housed in dry lot corrals. The lactating cows are housed in free stalls, and the manure falls off the cow and is flushed into the lagoon 3 times a day. And after this emission inventory was out, showing that dairies are the #1 source of these smoke-forming gases, the regulators thought, well, what is the main structure on a dairy contributing to air pollutants? And because this is where the manure goes, they said it's clear, it's the lagoon, which is the #1 source of these smoke-forming gases. And without any further study, they mandated the use of covered lagoons for all dairies. At the time, we had 2,000 dairies. So what they said was, we know dairies are the #1 source of smoke-forming gases. We think the lagoon is the #1 source within a dairy. And therefore, we have to cap all the lagoons, trap all the gases, burn them, and therefore get rid of these smoke-forming gases. So by far, this is a depiction here of a silage pile in California. I'm not suggesting anybody does what this gentleman does here, okay? But it just gives you a size comparison. These things are 30, 40 feet tall. And they are so steep with respect to their sidewalls here because the California dairies don't have a lot of land. Therefore, they give the custom choppers a small land footprint. And the custom choppers come and put the silage piles up and build them very tall. And as a result, they can't compact them nicely because the sidewalls are too steep. And there's the risk of rollover for the tractor. And therefore, the compaction in this area here is less than optimal, to say the least. So that's why we have such poor silage. Now, of course, nobody wants to hear that, but that's just a fact of life. We can do a much, much better job with our silage management, I believe. And that would be a win-win, both to the producer and also for the environment. This is our #1 source of air pollutants on California dairies, and not the lagoon. The lagoon, indeed, is the smallest source of air pollutants from our dairies. Why? Because the manure is so highly diluted. And many of those compounds that are smoke-forming have a higher affinity to water than to air. And when they have the choice to stay in the liquid phase versus the gas phase, they will stay in the liquid phase. So, of course, you have different regulatory issues here in Wisconsin compared to us. But 5 years ago, if you would have told anybody that we would ever have regulation on silage, everybody would have laughed about it. Now, that is the #1 regulatory train in the state. No doubt about that. Now, I want to shift your attention totally into a different area, which is the area of greenhouse gases and climate change. Similar to what I just described, the situation in 2002, 2003, when everybody said cows produce more smoke than cars, I found that the FAO, the United Nations FAO, in 2006 said, livestock produces more greenhouse gases than all transportation in the world combined, leading to climate change. Who has heard of Meatless Mondays? Only a handful? Really? No, come on. You've all heard of Meatless Mondays. That's something that's in the media all the time. Meatless Mondays and many of these campaigns are a direct result of this report that stated in its executive summary, the livestock sector is a major player responsible for 18% of greenhouse gas emissions. This is a higher share than transportation. So the United Nations FAO said cows and pigs and sheep and chickens produce more greenhouse gases leading to global warming than all cars, trucks, trains, planes, ships in the world combined. And the media had a field day about that, you can imagine. For example, I heard a show the other day where the moderator said, if you drive a Prius and you eat 1 burger a week, then that's the same as driving a Hummer. Sounds really funny, but if you're in the livestock industry, it's not that funny. And in addition to it, it's totally wrong. It's totally wrong. But I will now give you a little background as to where this story came from and what this is all about. I will go into some of the basics too, so that it's clear to everybody what all of this means. This is a photo that I took in Sweden not too long ago. It shows 3 burgers, a tofu burger, a turkey burger, and a beef burger. And those blue bubbles associated with these burgers are not the prices, but the carbon footprints. So in Sweden, you can now pick which burger you want to eat based on the carbon footprint. This here is an advertisement from a journal here in the United States. It shows how environmentally friendly a sheep is versus a Prius. Okay? All of these comparisons are based on this 2006 Livestock's Long Shadow report by the United Nations FAO that compared livestock to transportation and the carbon footprint of the one versus the carbon footprint of the other. And this is what I'm about to talk to you about today. What you see here is one part of the puzzle. We do know that in many regions of the world we see climate change occurring. For example, at the North Pole, we see that 10 years ago the ice cap was all the way where the yellow line is. Today it's where the white area is. We see a shrinking of the ice in the north. We see changes in the environment in places like the tundra in Siberia, where the soil that was previously frozen, solid frozen, is now warming up, releasing large quantities of methane. We see many regions in the world where climate change is clearly evident. And the discussion is not so much, does climate change occur? Most scientists, almost 100% of scientists would say climate change does occur. But the discussion is whether humans are to be blamed for it, or even partly to be blamed for it. That is where 20% or so of scientists say we don't think that humans are to be blamed. Okay? But it's not a discussion whether climate change takes place or not. It does take place. And it has always taken place. It's always been a cyclical up and down. But most recently, it has gone more up than down. So what is this whole story all about climate change? I will now give you a couple of really basic slides on what this is about. So the sun radiates solar beams down to the ground, down to the surface of the Earth. They are reflected back into space, where they would normally just go straight back into space. But there are gases, there are gas molecules like CO2, carbon dioxide, methane, and nitrous oxide, and others. And these molecules, when they are in the air, and when they're hit by a solar beam, they heat up. The best analogy I can give you is the analogy of keeping your coffee warm. You can put coffee into a styrofoam cup, or into a China cup, or into a Starbucks $20 insulated cup. Same coffee going in stays hot for different lengths of time. Similar to those different cups, those three molecules, CO2, methane, and nitrous oxide, keep the heat from the sun for different lengths of time. And that's also referred to as their global warming potential. So here are the three bad boys. CO2, that's what we're exhaling right now. Methane, that's what your cow belches out or the manure produces. And nitrous oxide. These three differ with respect to the global warming potential. This is most like the styrofoam cup, this is the China cup, and this is the Starbucks $20 cup. The methane traps heat 20 times better than CO2. The nitrous oxide traps heat 300 times better than CO2. And that's why methane and nitrous oxide are of great interest to those who want to reduce human-caused greenhouse gases. What's very important is this slide. It looks a little busy, but bear with me. On the x-axis here, you see the years 1750 to 2000. The blue line shows when within these 250 years fossil fuel was used. Fossil fuel being coal and oil and gas. Coal and oil and gas. So coal and oil and gas has, of course, accumulated and been stored in the earth for hundreds of millions of years. Within the last 50 years, about half of that fossil fuel, the coal, gas, and oil, has been extracted from the ground. All that carbon has been taken out of the ground. And what did we do with it? We've burned it. So where's the carbon now? It's in the atmosphere. So we've taken half of that carbon out of the ground, we've burned it, and now it's in the atmosphere. And now these molecules are hit by solar beams, and they are trapping the heat. That's what most people in the United States, like the EPA, but also most scientists blame as the main source of or the main contribution of human activity to greenhouse gases. That we're just putting so much carbon out of the ground into the air that now that's a source of warming up. This is what the EPA says. That's their official emission inventory from 1990 to 2008. On the x-axis, on the y-axis, you see the total amount of greenhouse gases as CO2 equivalents. what you see is that the number one area here, the main contribution of all industries to greenhouse gases, is the use of energy. And what they mean by that is transportation and energy production and use. This gray area up here is what the EPA says the total contribution is of agriculture to greenhouse gases. That's both plant and animal agriculture. Now, the EPA says 5.8% of all greenhouse gases are associated with animals and plant agriculture. Okay? If you tease out animal agriculture, EPA says all of animal agriculture in the United States contributes 3.4% of the total. According to EPA, transportation contributes 26% of the total, and energy production and use 31% of the total. Okay, so 3.4% of all of livestock versus 26 for transportation versus 31 for energy production and use. Why is that important? Because remember back to the EPA, to the FAO. The FAO, United Nations FAO says it's 18%. Livestock produces more than transportation. So the UN FAO gives this very high number, which is cited all over the media. Everybody has seen it. When I go to Los Angeles, San Francisco, everybody there has seen that number, 18%, and the comparison of livestock to transportation, versus the EPA saying it's 3.4%. Our numbers from our research that we do on campus at UC Davis or others here at Cornell or Wisconsin, they agree very well with the EPA numbers. So we really agree that the 3.4% is a good estimate. So the question is then, why are there such differences in numbers between the US numbers and this international 18%? And also, is it true that livestock can produce more greenhouse gases than all transportation? So I will now show you a couple of slides from Livestock's Long Shadow, from this United Nations FAO report. And I think they are very good, actually. The first one shows where in the world we have the highest concentration of livestock. And we always think of the Midwest or of California or those places. But as you can see, the areas with the most red are India and China. They by far have the most livestock. And they by far have the greatest growth. I want to give you two numbers here. First of all, the current human population in the world is 7 billion. We just crossed the 7 billion mark. 7 billion currently. Within the next 10 years, we'll add another billion to that. And then another 10 years, and we add another billion to that. Every 10 years from now on, we add another billion people to the world population. When you are your mother's age, we will have 9 or 10 billion people in the world. 9 or 10 billion people in the world. Why is that important? That is important to predict because while we know that the human population is growing dramatically, this is happening. This is a map showing the global areas of arable land. In color is the only area in the world that can be used for animal and crop production. This area cannot be increased. This is the only area that we can use to grow animals and crops for human consumption. So, and we are currently using all of that for agriculture, most all of that for agriculture. So basically we're already using all of the land for 7 billion people. What do we do in 30 years when we have almost 10 billion people? How do we feed these people? And that's what the United Nations FAO asked when they wrote their Livestock's Long Shadow report. In order to understand how they did this, the United Nations FAO, how they compared livestock to transportation and how they assessed the total impact of livestock, we have to explain really quickly here what they did. They did what's called a life cycle assessment, where you look at all the parts of a dairy or a beef system or a poultry system, from feed production to the animals, to the manure, to the soil, to the crops, pesticides, herbicides, everything that's related to producing a gallon of milk or a pound of meat. And that's what you have to do. It's called a life cycle assessment, and that's the tool you use. If I were to ask you, what was the carbon footprint of you driving from your farm to the expo? What goes into that calculation? What would you say goes into that calculation? Gas, burning the gas, right? What else? Yeah, mileage. What else? Manufacturing of the car. Is that true? Yeah. Somebody had to produce the steel and rubber and plastic and all that stuff to put the car together. Yes. Anything else? Somebody had to build the roads you're driving on. That's part of that too. Somebody had to get the oil out of the ground in Saudi Arabia, and somebody had to refine it, and somebody had to ship it from the refinery to the gas station. And eventually you took that gas, put it in your tank, and you burned it. But the carbon footprint includes everything associated with you driving from A to B. And that really includes the whole shebang. If you want to compare two industries, then you have to do a true life cycle assessment, which includes every aspect of the production of that product. However, that's precisely what the FAO has not done. That's what they should have done. That's what they have not done. They have done a total true life cycle assessment for livestock, but for transportation, they only looked at how much greenhouse gases emissions are produced when you burn gas. They didn't look into the production of vehicles, planes, trucks, ships, and so on, roads, getting the oil out of the ground, refining it, all this big part of it, but only the burning of gas. And so for transportation, they only looked at the direct burning of gas versus for livestock, where they looked at everything that flows into it: pesticides, herbicides, fertilizer, land emissions, the animals, the waste, everything. So what I'm saying to you is that this was a classical apples to oranges comparison, factoring everything for livestock and only a small section for transportation, and then putting out in the executive summary that the one is worse than the other. And that is what has affected the livestock industry, not just here, but internationally to the largest extent. Everybody who has an axe to grind with animal agriculture will say, we all know livestock produces more greenhouse gases than transportation, according to the United Nations. So we wrote this up in a publication, Clearing the Air, Livestock's Contribution to Climate Change, with two of my graduate students and I. And we published it in a peer-reviewed journal, Advances in Agronomy. And then we went to the next step. We wanted to make sure that it's not just something that goes out in a peer-reviewed scientific journal for a few of us scientists to read it, but that it has the potential to inform public policy. Because it's not just good enough for us finding something and publishing it, and for a handful of people to read it, but for the people out there to hear about it. And so we went further, and I will explain that in a minute. So globally, the FAO said all of livestock's contributions, 18%. In the United States, we find it's 3.4%. So for example, the entire beef sector might be something like 1.4% of the total greenhouse gases. Let's just follow the Meatless Monday campaign for a second. Let's say all Americans would stop eating meat for 1 day a week. And let's say the total carbon footprint of beef production is 1.4%. And you can do the math. 1.4% divided by 7 is 0.2%. That is what would happen if all Americans would stop eating meat 1 day a week. Then we would have a 0.2% reduction of greenhouse gases. We would never be able to measure that as scientists. It's impossible. It would be an absolute minuscule reduction in total greenhouse gases. Versus, I want to remind you, versus 26% of total contribution to climate change being associated with transportation. Of course, people don't want to drive less or different vehicles or so. They want to blame the cows. Remember that photo there? With all the homes and the dairy? That's what they like to do. They don't want to think about how to cool their homes, how to heat their homes, how to drive from A to B. They want to just blame the cows. So what is important to say is there are large differences across the world. In developed countries like the United States or Europe, we have learned to be very, very efficient. We have learned to produce an optimum amount of milk or meat with as few animals as possible. And that is not the case in many developing countries. So while in a country like the United States, livestock contributes 3.4%, in a country like Paraguay, it's 50%. They have twice as many cattle as they have people. And they're clear-cutting trees in order to establish pastures to graze animals. And by taking the trees down, they take a sink down, because trees can take on CO2 and give off oxygen. So in the United States, greenhouse gas contribution of livestock is dwarfed by other industries like transportation, energy, and so on. In developing countries like Paraguay, it's much higher, the relative contribution, that is. In Ethiopia, their livestock contribution might be as high as 90%. Why? Because they hardly have any vehicles and industries and so on, but a lot of livestock. So if you now want to come up with a global number, You put the United States and Paraguay and Ethiopia and the additional 197 countries into one pot and come up with an average, then that average number is very high. And what the media has done is they have taken their global average number and they've applied it to California or to Wisconsin or to New York or to Germany or to Australia. And that is fundamentally flawed. It's a global number. It was never intended by the FAO to be used regionally. But that is precisely what happens. If you read Martha Stewart or whatever all these other magazines are called, you will find that 18% number everywhere applied to your specific region, putting the blame to your product. Here is another slide taken out of Livestock's Long Shadow, which is a good one. It shows on the left side the developing countries of the world, the third world countries. On the right side, the developed regions in the world, so the United States, Europe. As you can see, these in color here are greenhouse gases over the years 1990 to 2020. In the third world, those greenhouse gases associated with livestock production are going up and up and up and up. Why? Because their demand for livestock protein is exploding. It will double within the next 30 years in countries like China and India and many other Asian countries. Why? Because they have more and more disposable income. They're getting richer. Whereas in the developed countries of the world, we are producing an increasing amount of animal protein with the resources we have. We are not increasing, but we are plateauing total amount of greenhouse gases per unit of product. So we have learned to optimize input and output and therefore limit our environmental impact per unit of production. This slide was given to me by Henning Steinfeld, who is the author of Livestock's Long Shadow. He came to visit me in Davis after the report came out and after we had a little discussion about things. And you see on the one side ruminant meat, then dairy and non-ruminant meat, and the different colors indicate different regions in the world. This is the US, this is Europe, and this is Brazil. Now, why are there such differences? Because, first of all, of efficiencies, but secondly, because of differences in research use. In Brazil, there has been a lot of clear-cutting of forests, and that is a huge impact on total amount of greenhouse gases. So, according to this United Nations FAO Livestock's Long Shadow report, intensification provides large opportunities for climate change mitigation. Oh man, my time is running away. I already gave you these numbers here. 18% is not a number that can be used for any individual region in the world. Okay, this is not right and this is flawed. The biggest issue of Livestock's Long Shadow is that they have used two different methodologies to compare livestock to transportation. And this is an apple to oranges comparison, which is flawed. I will just give you this comparison here. A colleague of mine, Kappa, wrote a comparison of 1944 versus 2007 dairies. And she found that today, in order to produce the same amount of milk, we produce 20% less animals, 23% less feedstuff, 35% less water, and 10% less land to produce the same amount of milk as we did in 1944. So what's also interesting to state is, in California, we produce on average 20,000 pounds of milk per cow. In Mexico, the average production per cow is 4,000 pounds. It takes 5 Mexican cows to produce the same amount of milk as one Californian cow. And we're talking Holsteins here. Why? Because we have learned to be so efficient. We have learned to provide health care, get good genetics into our herds, optimize basically everything around the animals, comfort and so on. That had a huge impact on how much milk we get out of a unit of animal. I want to briefly point at some of the media responses, because as I said, it's not good enough to just publish something and share it with some scientists, but I presented this at the American Chemical Society, which is a 13,000 member annual event, and Associated Press was there, and they interviewed me, and after they do that, your life turns into a living hell, because their information goes to every news station in the world within a couple minutes. So they write a story and then it goes out. So I will now show you some of the media responses to this discussion. The first one was the BBC. They interviewed me and then they interviewed the United Nations FAO folks. They interviewed me and then wrote a story called UN Body to Look at Meat and Climate Link. UN specialists are to look at, again, at contribution of meat production on climate change after claims that an earlier report exaggerated the link. They then called Pierre Gerber, one of the contributing authors of Livestock's Long Shadow, who was quoted as saying, "I must say honestly that he, Mittlöhner, has a point. We factored everything in for meat emissions and we didn't do the same thing for transportation." So they offered publicly that they had made a mistake, which is great, I think, which is honorable, but the horse had left the barn. And this quote they had made of comparing livestock to transportation was in the executive summary and therefore cited by all of those journalists in the world who have an axe to grind and want to get rid of you. So now I show you a couple more news articles. This is the equivalent of Newsweek in Canada, McLean's, and 1 year after Livestock's Long Shadow came out and a year before our report came out, they had this title story, "Save the Planet, Stop Eating Meat. The UN says so, and so do a growing list of school boards. Meat, the new eco-enemy." The same journalist who wrote this article interviewed me after we published our article and now said, "Where's the beef? Scientists take a second look at UN numbers that have led many environmentalists to forego meat." Totally different tone in the article. The next one was The Ecologist. 1 year after Livestock's Long Shadow, they had this as a title story here. And the same journalist writing this story interviewed me and now wrote this story, "Have we got it right on meat and greenhouse gas emissions? Analysis showing lower greenhouse gas emissions associated with intensive livestock production could pose a challenge to our views on best farming practices." This was an excellent article by the nation's leading journalism school, Meat versus Miles. I strongly recommend it if you're interested in the topic. This was an awful one, meat eating versus driving, another climate change error. They had to run 3 corrections on this article because they really had it wrong. This was CNN. They quoted me as saying, "Don't blame cows for climate change." This article here was read by 20 million people. By 20 million people. So it's one thing to publish an article, as I said, and put it in a peer-reviewed journal article, but it's very important to go to the next step, which is informing the public, because by doing that, you can really affect public policy. And that's what we wanted to do. We wanted to inform public policy so that they don't just hear one story over and over and over again that we believed was wrong, but that they have a more balanced view. The UK wrote stories, and Australia, and it went on and on. This is from China here. Never knew how to spell my name in Chinese, but there it is, or there. This is India. It went all over the world. Why? Because it affected public policy everywhere. Livestock's Long Shadow affected the entire world and public opinion toward animal protein. Whether it's milk or meat or eggs, it doesn't matter. It was all affected. Now, this amount of media attention has really affected also the FAO. What they did was they wrote follow-up reports, now breaking down the world livestock sector into regions like US and other places. And this is the first one here that came out, their first follow-up report showing different regions in the world and total amount of greenhouse gases. And as you can see, North America has the lowest greenhouse gases per unit of production. As I said previously, 5 Mexican cows equal 1 US cow. So if you take North America and break it down into Mexico and the US column would be approximately half of what it is on this slide. So by far, we have learned to produce so efficiently that the environmental impact per unit of production is the best anywhere in the world. Now, we have to do a much, much better job communicating that with our public, because the public here is led to believe that what we do is harmful to the environment, it's cruel to the animals, it's unsafe, and so on. And that is a job all of you have to do. Nobody can do this alone. All of us have to do it together. The same authors who wrote Livestock's Long Shadow now write a follow-up report called Shrinking the Shadow. And their key conclusion will be intensification is the key to mitigation. And what they mean by intensification is using optimized genetics, nutrition, healthcare, and so on. Basically, look at those countries who have managed to optimize the production. And that's what we need to do in the rest of the world. And with that, I close my presentation, and I'm happy to entertain any question you might have. Yes, please.
I thought the whole point of Meatless Seventh-day Adventists are heavy on vegetables and fruits. They live longer, they have less heart disease, less diabetes. So I didn't even realize, I thought Meatless Mondays were to get us all to eat better and be healthier as people. The other comment I had was that picture that you really like, where you've got the 1,000 urban people here and the 1,000 cows here. First of all, 1,000 cows aren't many cows. We've got the big dairies coming into the state, but we have a right to farm law here, which would state that if the farm is there and people come in and then they come at it with a nuisance lawsuit, they are going to have a lot of evidence that they've got their nuisance out of the way. So we're in a little different state because, I mean, a little different situation because we got the right to farm law.
Okay, so first of all, the Meatless Monday. The Meatless Monday originated from Johns Hopkins University, and if you go to their webpage, you will see it's all about climate change. I mean, 90% is about climate change, and then they add a couple other components which include, and by the way, it's better for your health too. But the main driver that they have used is to reduce the carbon footprint. And then the second one, but minor one, is to improve human health. But they didn't really have the evidence to prove that, so their focus is on climate change. Your second point, we used to have the Right to Farm Act in California. In fact, we still do. But it's being overruled over and over and all over the place. I'm currently involved as expert witness in 5 lawsuits. Not just in California, but also in states like Washington and Nevada. And it's happening everywhere now where farmers are sued either by neighboring communities or by very powerful activist groups, including organizations like the HSUS, with an annual budget of $150 million. I've just been an expert witness in a lawsuit where that very organization sued an individual poultry producer, not for welfare reasons, but for ammonia emissions. The first time ever. So, and that happened in a right to farm county. So when push comes to shove, then what happens is they go to a court, they say, this neighbor here affects or produces nuisances, and I have a right to enjoy my house and my garden, and I want to be able to sit outside, and I can smell this dairy or this poultry operation or whatever. And more juries are populated by urban people, and they just rule in favor of the neighbors.
Could you expand on, you said California has air quality, you have to have an air permit.
Yes.
What actually does that mean, you have to have an air permit?
That's a good question.
Requiring of you?
So what does an air permit require of the producer? First of all, you have to go through a lot of paperwork. You have to say, I have 1,000 cows, 2 freestall barns, I use flushing. You describe exactly how you operate your dairy, how many engines you have, and how large your lagoons are, and how deep they are, and how you manage them, how often you empty them out, and use the lagoon water to fertilize crops. All of that stuff is on paper. So the air district reviews that paperwork, and they will get back with you with respect to is what you do best management practices or not. But more importantly, you're kind of locked into what you put on paper. If you want to change anything to what you had put on paper, you need to get a new air permit for that before you make the change. If you want to expand your herd or build something new on your dairy, you need to get an air permit for that. If a neighbor drives by your dairy and sees a dust plume coming up and feels like that shouldn't be there, that neighbor can call the air district. The air district has to come to that dairy and investigate if everything that's going on that dairy is in accordance with the rules and regulations. They have to. And even if there is nobody complaining, that air district will still send one inspector to each dairy once a year to check that everything is okay.
The EPA has not set standards for hydrogen sulfide
That's
and
right.
ammonia, so how are you in California, what standards are you using?
That's a very good question. The EPA has not set standards for hydrogen sulfide, let's say. There are health standards for it. Health standards that, where health organizations say if you exceed that concentration, then that might be hazardous to your health. The same is true for ammonia. But these operations are not regulated based on how much they emit on any given day, but how much they emit totally over the course of a year. And then they are put into a category. For example, if you have more than 500 cows, they just assume that you produce over a threshold total amount of ammonia, hydrogen sulfide, and so on, and then you need an air permit. It's not really very detailed and very precise and accurate what they're using, but they're using some overall thresholds, and they are based on cow numbers, not emissions. Yes?
Is it true that a chunk of mature forest doesn't really add or take CO2?
Well, is it true that mature forest,
adding the animals and the plants and everything is a perfect cycle that really...
Right.
The general idea is that if we keep the forest, they will absorb all the CO2 that we produce.
Yes.
But I think this is wrong because it seems like a chunk of perfectly mature forest
Yes.
is in perfect balance with
Yes.
itself. So
Yes. Did everybody hear the question? So the issue of plants, how do plants fit into the overall carbon picture? Plants take on CO2 and they give off oxygen. So over time, plants sequester, assimilate carbon, and that's what the wood is. So they take the carbon out of the air, they make it put it into the structure of the wood, and if you harvest the timber and make it into furniture, then that's the carbon that this plant sequestered during its lifetime. If you burn the forest, then the carbon that was assimilated and sequestered goes into the air as CO2, if you burn it. So you basically, if you have trees, take the carbon on, and then if you use the trees for timber, you basically store it away for as long as the furniture or whatever you use it for will last. It's a different question with forages, grass and so on. They will also take on CO2. And if cattle eat it, if they eat the grass, then they will do what with it? Then they will produce some methane, if they are ruminant animals, and they will respire carbon and put out CO2. So carbon dioxide from animal agriculture is considered a net zero contribution because what the plants sequester and assimilate, the animals eat and respire. And therefore CO2 is not considered a contribution of animal agriculture. But methane is and nitrous oxide is. Nitrous oxide, by the way, is this gas that has 300 times the global warming potential of CO2. Nitrous oxide comes from land-incorporated nitrogen. Whether that is chemical nitrogen, chemical fertilizer, or whether that's animal manure, as soon as you have nitrogen in the ground, there are microbes that will take that nitrogen and convert it. For example, from nitrate into nitrous oxide, which is this greenhouse gas, and then further into other compounds. And that's the main contribution of agriculture to nitrous oxide. One thing that's very interesting, I'll show you that really quickly here, because I skipped over it, is this slide here. The emission inventory of the EPA shows that south of the x-axis, there is a gray area. What does that mean? That means there are industries that reduce greenhouse gases. These are all these industries that either have soils or forests, and that means there are sinks for greenhouse gases. And these sinks are two industries, forestry and agriculture. If you have a range, and you have rangeland, and organic soils with forage, that will sequester carbon. If you have plants, they will assimilate carbon and reduce. They are a net sink. So agriculture and forestry are the only two industries that have the capacity to trap carbon and store it. Yet guess what the only two industries are in the world that have never been really on the table in Kyoto and Copenhagen and the other climate change conferences. It's forestry and agriculture. Never at the table. And I think that's a travesty. I think it's really sad that agriculture as a whole, instead of being proactive and involved and saying, we are part of the solution and we want to do our share, instead of doing that, for the most part, agriculture says, leave us alone. We are private people. We don't want to engage with the public on this issue. And I think that's a big mistake. And I think we have a real opportunity. People want to know where their food comes from. And I think we need to do a much better job telling them that. We must do a much better job jointly of telling them where their food comes from. Once they get to see a commercial dairy, or whatever dairy you have, they will say, oh, this is not the way I thought it would be. I thought they're all on pasture and so on. But once they see it, they don't object to it. The reason why they object to it is because some activists can tell them whatever they want to tell them, and they have no other side of the story. And the other side of the story, the egg side of the story, cannot be some PR. People don't want to hear PR. People want to hear, where does my food come from? Show it to them. You have nothing to hide. I've seen hundreds and hundreds of dairies and feedlots and so on. There's nothing to hide. The problem is that the public feels that there's something secretive. And all they hear is from the other side that you're cruel and polluting and secretive, and that's a big problem. About half a year ago, I don't know what my time is like, I forgot my watch. About half a year ago, I was on stage with a gentleman by the name of Robert Kenner. You might not know who that is. He is the executive director of Food Inc. Food Inc. Has anybody watched Food Inc.? It's the #1 documentary in the United States. The #1 watched documentary in the United States, and it deals with animal agriculture. I urge you to watch it, because this is now material used as mandatory teaching material in middle schools all over the place. I asked the executive producer of Food Inc. in front of 400 food critics and top chefs, I asked him, what's your background in animal agriculture? And he said, I have none. He said, you know, no background in animal science or veterinary or so science. I said, so how did you come about making this film, and such a successful film? He said, well, what I did was I contacted 100 animal producers, big, small, you know, commercial, organic, and so on. And of the 100 I contacted, 3 responded. 3 responded. And he said, and they are the 3 in the film. They're the only ones I could really get material from. And the other ones that are in the film are those that I took from canned material. And you can imagine where that canned material came from. So unless you really want to allow the other side to portray the picture of your industry, you have to get involved. There's nothing wrong with informing people. I teach a class with 270 undergraduate students. They come from Los Angeles, San Francisco, Sacramento. They will be decision makers of the future. And guess what I do with them? I take them onto farm trips. We go onto commercial dairies, feedlots, swine operations, poultry operations. We do stuff on campus. We do all the husbandry practices that are being done on your operations. And they love it, and they think this is great. And they take those photos and make them profile photos for their Facebook pages and so on. This is very, very important. This is my share, but the producers have a share too. And I think what is also very, very important, and I tell every producer I see that, I think that those few bad apples that are out there and that are always used by activist groups, they have to stop being bad apples because they give everybody a black eye. That's a big problem. These films that we see from time to time, they are watched by hundreds of thousands of kids, and they think this is reality, this is the norm. This self-policing issue, I think, is very important. If people are cruel or polluting, they must stop being cruel or polluting. And they must stop giving everybody a black eye. And I really think that you as a whole have a responsibility of making that change happen. I think it is very, very important. I don't want to stand on the soapbox, and I feel I do, but I want to thank you very, very much for your attention, and it's really fun to be here. Contact me if you have questions.